Hello, dedicated and lively biostatisticians. This is the second part of the Making the Right Choices lecture for week 2. So, just to reiterate, what we really want you to be able to do at the end of this class is know what statistic to choose, right? Picking the right statistic, because computation is really trivial. You don't have to know how to calculate statistics, and like I said at immersion, we're not even asking you to memorize formulas. The computer, SPSS, is going to do the heavy lifting for you. It's going to do the hard work. And, we used to pay statisticians to do that because the calculations were complicated and who wants to actually do equations and calculus and things like that. But we don't do that anymore. So why pay a lot of money for something that you can do just in a few click, 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 right? So the only really difficult part of all of this is knowing when to do what, and that's pretty straightforward. So this next 10 minutes or so of a lecture, maybe even less, is a reiteration of something that we did talk about at immersion. What we want you to be able to do is know which statistic to use before you even know the procedure for calculating it. Okay, being able to identify the right statistic that makes sense for the data, and being able in articles to look at the data and go, does this make sense? I mean, don't think that just because it was published in a nursing journal, it was done right? We want you to be able to understand how to interpret those statistics. Does it make sense? Is the procedure correct for the type of data that they're working with? And then to know how to interpret the substantive meaning. So I'm going to toss two statistics out there without any meaning. I want you to remember 10, remembering it? Okay, 10 and 80%. And these two numbers are from the Zellner et al. Article that you all read. Okay, 80% of all analysis from 400 articles in key nursing journals that were reviewed, 80% was based on only 10 statistics. This isn't rocket science. These are not really complicated statistical ideas. Okay, 80% of all of the analysis was only based on 10 very basic statistics. You can do that. You're doctorate students. I have faith. So, what we need you to know, in order to pick the right statistic, all you need to know, the only magic that's in there, there's none of this witches at a cauldron, double, boil and trouble, right? All you need to know, the purpose of the test and the level of measurement of the dependent variable. Okay? Two things, the purpose of the test and the level of measurement of the dependent variable. So for the purpose of the test, what do you want to do? Are you comparing the sample to a population? Is there a standard out there, a standard of care that you're comparing to? Is there a standard infection rate, a national infection rate that you want to see? Are you above or below it? Are you comparing the sample to a population? Are you comparing variables to each other? Are you comparing groups to each other? Are you comparing trials to one another? Are you comparing groups and trials? That's possible too. Second, what is the level of measurement? Is it nominal, ordinal, or interval ratio? And for a good discussion of that, go back to some of the early slides from immersion, right? Nominal is just a name. Ordinal are categories with a specific order. So going back to nominal, just a name, colors. Okay? Colors are just a name. There's no specific order unless you're imposing, say, a color wheel, for example. Otherwise, colors are just a name. Gender, just a label. There's no specific order. Women don't come before men or vice versa, although we could get into the political discussion about that, right? Generally speaking, just a name. Ordinal means that there's a specific order. Days of the week. Monday comes before Tuesday, comes before Wednesday. Months. January comes before February, comes before March. Interval ratio are things that can be measured using numbers that have meaningful distance from one another. So temperature is interval. We say age is just a number. That's interval ratio. The next thing that you need is the handy-dandy M-squared matrix, Mary's matrix, that we gave you at immersion. All of the information you need is right there. Okay, if you know the purpose of the test down along the left-hand column, and you know the type of data up along the top, you in this matrix you can find what tests will be appropriate. For example, let's say you have a randomized experiment comparing 3 groups after treatment. You have a standard of care group. Okay, you've got a group that's receiving the new treatment, and then you've got a group that's just watchful waiting. Okay? The outcome is the size of their tumor in centimeters. So what do we need to know? We need to know what's being compared. So what's being compared here? 3 groups. Standard of care, new treatment, watchful waiting. We need to know the level of measure of our outcome variable. Centimeters, that is an interval ratio measure. So we go to the matrix. Everybody get your matrix, okay? Have it out here in front. You should be looking already as I'm talking up along the top, down along the left-hand column, figuring out what we need. So the type of data that we have, interval ratio. So we're going to go right down that last column. What we're comparing, more than 2 groups, 2 or more groups. It's a comparison of groups. And so that gets us over into this little cell here in the matrix, right? We could do an independent samples t-test if we had 2 groups, but we have 3. So we could do a one-way ANOVA if we have more than 2 groups. So there we are, we have a one-way ANOVA. Piece of cake, right? Now you need to know, now you know you need a one-way ANOVA. So at the end of this class, you're going to go, one-way ANOVA. I know how to do that. Or at least I know where to read the instructions to make SPSS do it, and I know what it means. And that's the most important part. And then, as if that magical matrix isn't enough, we've also provided you with another matrix, okay, that gives you even more information and is really useful when interpreting journal articles. And in fact, as you're doing journal articles for this class, I hope you're referring back to this matrix. Okay, it's a 2-pager. I'm only showing the first page here, but like I explained in immersion, it gives you for each statistical test the purpose of the test, the types of independent and dependent variables, what the null hypothesis would be, the alternate hypothesis, the type of samples. All of that information is right there, and that helps you read these articles and see, okay, did they do it right? Do their assumptions make sense? Is this plausible? Because when it comes down to it, the statistic by itself is never enough. It's the story. It is the author's job to convince you that the evidence supports their conclusions. Just like when you're working on your CDP, I keep saying CDP, Clinical Scholarly Project, CSP, Clinical Doctoral Project? I don't know. When you work on your Clinical Scholarly Project, your CSP, your job is to convince the faculty and your readers and audience at presentations, your job is to convince them that your conclusions are supported by your evidence.